All right, for this lab, the molar volume of a gas lab, we have not a whole lot of setup that we have to look at here. We have this 1,000 mil grad cylinder, which is just a kind of, doesn't have a function as far as measurement for water. It's just here for the Udeometer, which we'll get to in a second. You have a little bit of magnesium strip. You've got this little stopper with a nichrome wire on it, and you have this instrument called a Udeometer. Now, it's kind of looks like a burette, except this end here is closed. It's like a giant test tube. And you have this end over here, which of course is open. I've already kind of filled it with water. And what this does, what it's useful for, is measuring the volume of a gas. Otherwise, it's really kind of difficult to figure out how to do that. It's got measurements just like a burette, where it starts off at 0 down here at the bottom, and then it measures in milliliters of gas starting here, so 1, 2, 3, 4, 5, all the way up to 50. And once you get past that, then you're out of luck. So however this runs, hopefully it only measures something less than about 50 milliliters of gas. So how we would actually do this is we would have this empty, and you would add in about 5 mils of some concentrated 6 molar hydrochloric acid, a strong acid, hydrochloric acid. And with that, I would give you some length, pre-measured length of magnesium ribbon. It's pure magnesium. And with that, I'm not going to do you any favors. I would give you a relationship between the length of the magnesium in meters and the mass of the magnesium in grams. So you would measure this in something in centimeters or millimeters, and you'd have to transfer that length of magnesium in millimeters or centimeters into grams of magnesium. Okay, and if I had grams of magnesium, I can of course turn that into moles of magnesium. So I have that sitting in here, and I'm going to wrap it in this nichrome wire, so it's all kind of in this little stopper. And then this needs to be 100%. I've got the acid sitting down here in the bottom. I fill the rest up with water. The acid is more dense, it's going to kind of stay down here. And then I got to make sure this is all the way filled up with water, try to get as much of the air bubbles out of here. And then I would stopper it with the magnesium in here, and then make sure it's all like only water, there's no air bubbles here at all. And then I would gently turn it upside down and place it into this grad cylinder. And eventually you're going to see the little squiggles of the acid, because it's dense, it's going to sink and come down and react with the magnesium. So metals and acids react really well. It's an oxidation reduction reaction. The magnesium is going to react by becoming oxidized. It's going to lose electrons on the metal. So the metal loses electrons, becomes a positive ion. And those electrons are going to be transferred to the hydrogen. And the hydrogen is sitting in here as an ion. It's going to gain electrons, reduction, and it's going to form a gas. And you're going to see these little bubbles floating in here. And they're going to gather up here at the top. And just to kind of exaggerate this point here, I'm not actually going to run this. So we'll just kind of exaggerate this point. And then I put this in here, and you can see that I've got some amount of gas that I've kind of put in here. And of course, again, I'm exaggerating this. And we'll pretend that that's hydrogen gas. So this is all going on sitting in this grad cylinder. Now, if I set this up correctly, and I didn't, let's add a little more air, or in our case, hydrogen gas, to this, and we'll put it back in here, nice and gentle. And then we can see that there's like a line of the gas in the container. Now, what we have to be careful of is that these two water levels are the same. If it's too deep, think about like you going deep into a pool, the deep end, you feel that pressure, and that's what's going on here too. So it's having less gas volume in here because it's being pressurized because it's going too deep. If I raise it too high up, this level goes down because of gravity and less pressure. When you have it the same, the only thing that's causing this volume in here, a very specific volume in here, is the air pressure that's pressing down on the surface of the water. And if these two are the same, I can now get an accurate measurement of the gas that is in the Udeometer, this gas measurement device. So I would look at the volume on here, and I get something. In this particular case, it's like 31 point something. And again, of course, I just made this up. So that's all the measurements we have as far as here goes. But the things we have to take a look at is, okay, what measurements do I need to do this lab? We need a few. One is some relationship of density of magnesium to length. So that relationship. And I'm just making this up. We'll say it's 1.405 grams per meter is a relationship. I'm just making that up. It's 1.405 grams per meter. And I give you a length which is like 1.6 centimeters. So if I gave you that length, you could figure out a mass of magnesium. Something else I might give you is the pressure, the atmospheric pressure we have today. And if you looked up on a weather site, they always give you these goofy numbers. And for example, if I look it up today, and I will give you something more specific for the lab, it's like 29.77 inches of mercury. Weird, ridiculous. We don't want inches of mercury. We need to use something either like millimeters of mercury, we can do that, or something I prefer is atmospheres. Atmospheres is a really convenient use of pressures that we use in here a lot. So we're going to go to atmospheres of pressure. Other important piece of information, we would need temperature. And for temperature, if I looked up today's temperature, for example, in this classroom, because everything in this room is room temperature, so the water, the air, the table, everything here is room temperature. I could tell you that it's, for example, it's like 68 degrees Fahrenheit, which is not at all useful. We would have to turn that into, for example, Celsius. And if I had Celsius, I could transfer to something which is much more valuable, especially for gases. I could turn that into kelvins. And with kelvins, I have now a pressure, I have a temperature, and then I need a volume. The volume comes right out of here. So that volume would be something that I have measured directly. And so I have these three pieces of information, which are fabulous. Now, I can also find a relationship of the number of moles of magnesium. So if I had, again, this length, I can take grams, and I'll just put it in the middle here, grams, and turn that into moles. And if I have moles of magnesium, I can get moles of hydrogen gas based upon the chemical formula or the equation that relates those two. So magnesium metal plus hydrogen ions yields some magnesium ions, put that aside, and then I need some hydrogen gas. So I need to figure out a chemical equation that produces some amount of moles of hydrogen gas. Okay, so I have that information that we worked with. Now we need to go on to figure out, well, how can I figure out how much gas was produced at a different set of circumstances? So this gets into some equations like combined gas law or ideal gas law. We'll deal with the combined gas law. If I change some of these and say, well, I have these conditions and I've measured them directly, what would it be if I change this from this set of data to another set? So I'm going to say, instead of whatever pressure it is, what is it if I had a pressure of 1 atmosphere? And my temperature was not whatever this room temperature is, but it was 273 Kelvin. And my moles, moles I think I'll just leave alone. I may change that later, but I think I may just leave that one alone. I'll tell you on the data what I want to do with that. But having these couple of what we would call standard conditions, how does that affect the volume? What number do you get there? So that'll be the lab that you're going to run. I will give you some data, which will be a specific length. I'll give you an atmospheric pressure, and I'll give you a temperature of the room that all this is taking place. And you'll have to manipulate that around for these other conditions. Okay, there we go.